Hi, everyone. In this second lecture for Unit 3, we're going to look at how robots or satellites have been used to explore the inner solar system. So our learning unit outcome is to be able to explain the significance of human and robotic space missions. In the last lecture, we focused on human space exploration, and now we'll look at robotic space exploration. And so we'll have four essential concepts that you'll need to know by the end of this lecture. First, I want you to be able to describe how the Soviet Union was able to explore the moon early on using robotic spacecraft. Then we'll talk about the few missions that have been taken to Mercury. And then we'll talk about the challenges of exploring Venus. And then finally, we will talk about our long history of exploring Mars. Okay, I want to pose this question to you first. Which object has been explored more than any other in our solar system? So here we have one of these inaccurate depictions of our solar system. And in the solar system, you could probably say that we've visited many of these. Which do you think we've explored more often than others? Okay, now I give you a chance to guess. I'm going to reveal the answer. The answer is revealed in this really interesting infographic. This infographic shows all of the historic space missions that we have taken to the various planets and moons in our solar system. So as you can see, we're located here. And then all of the lines that emanate from the Earth represent individual satellites that we have sent out into space. And as you can see here, the most amount of lines are encircled around the moon. And so we have attempted or have explored the moon more than any other object. And this makes sense. The moon is our closest neighbor. It is in orbit around us. It is easiest to get to. And so that would make sense that we have explored and attempted to explore it the most out of every other object in the solar system. So let's talk about the moon first. Early robotic space exploration for the moon were largely revolved around the Soviet Union sending robotic spacecraft to the surface of the moon. This was their Luna program. Luna 16, 20, and 24 were all missions that landed on the surface of the moon and were able to gather up samples of lunar soil and return those samples back to Earth. Here is a museum display of one of those landers. We can see that it has a robotic arm capable of gathering samples from the lunar soil. They were able to return less than 1 pound, which is much smaller, much less than what was returned by the Apollo astronauts. However, they explored very different regions of the moon than were accessible by the Apollo astronauts. The Soviet Union also developed the first rover to land and operate on another planetary body. This was the Luna rover. The rover is shown here in a museum display, and we can see that it has a large solar panel capable of powering the unit. Here's all inside of its computer systems, and I believe this is an antenna for sending its signal back to Earth. These rovers were incredibly successful, actually. They had 2 of these rovers, and they were able to travel over 31 miles across the surface of the moon. This was far and beyond the record for most distance traveled by a rover up until one of the Mars rovers was actually able to travel further than that. Okay, so now moving on to Venus. Venus is actually very difficult to get to. Venus is covered by a very thick atmosphere, and so it is difficult to explore the surface of Venus. However, the Soviet Union was able to accomplish this through their Venera program. This was active between 1961 and 1984. This mission brought back to us our first radar images of another planet. Radar was used to see through Venus's very thick atmosphere. Then they were able to make the first entry of another planet's atmosphere. The probe and the lander that they sent down to Venus was able to sample Venus's atmosphere and learn more about its composition. Then they were able to make the first landing on another planet. And here we see the first images that were returned. As you can see, it's a very rocky environment. The surface environment is very hot on Venus. They have basically a runaway greenhouse effect where its atmosphere is retaining most of the thermal energy radiated by the surface. And so all of the sun's energy that is hitting Venus, the atmosphere is keeping that that energy close to it, and it's basically cooking the surface of Venus. I think temperatures are above 600 degrees. Definitely a very hot, very hazardous environment for any sort of spacecraft that we sent. The spacecraft that landed on the surface of Venus did not last long. I think they maybe survived for a couple of minutes, maybe 15 to 20 minutes at most, before their circuits and systems began to fail. Okay, then moving on to Mercury. Only a few missions have been sent to Mercury. I think a total of 2 have been successful in sending us images of Mercury. The first was the Mariner program. This was NASA's first program to really begin to survey the different planets in our inner solar system. The Mariner program brought us our first planetary flybys, first orbiters, meaning that they put the satellite in orbit or around another planet, first planetary assist maneuver, which is where you go by a planet to use the planet's gravity to accelerate the satellite in a new direction. They were the first ones to make the atmospheric and magnetic measurements of other planets as well. So looking at Mercury, Mercury was explored by Mariner 10 in 1973. These were the first close-up images that we had ever seen of Mercury. And these would not get revised or updated for another 30 or so years until the Messenger spacecraft arrived at Mercury. And as you can see, if you look at Mercury here, it sees that it's covered by a number of many dozens or thousands of impact craters over the surface. The reason for this is that Mercury is very close to the sun. The sun's gravity is very strong, and so any object in the asteroid, any near-Earth asteroid that is passing through the inner solar system is going to be accelerated as it gets close to the sun. And sometimes Mercury is going to get in the way, resulting in a very large impact and a formation of a large impact crater. So here we see a close-up image taken by the Messenger spacecraft, and it highlights the numerous impact craters that are covering the surface of Mercury. Okay, and then finally we get to Mars. Mars is probably the planet in the inner solar system where we've dedicated the most amount of attention in recent years in our attempt to look for evidence of water and ancient life. Mars is actually incredibly difficult to get to. Mars has the curse on it. Some would say that about half of the missions that get sent to Mars fail. And this is due to its distance out in the solar system. It's about half the distance, about 1/2 AU away from the Earth. And then once you get there, you have a relatively small planet that you have to get in orbit around, or that you have to navigate your spacecraft to land on its surface, which can be very difficult. Here's a sort of another infographic showing the difference between the different successful and failed missions to Mars. Failed missions are highlighted in red or orange, and the successful missions are highlighted in blue. And as you can see, the United States has excelled in its ability to have successful Mars missions. First successful missions were with Mariner 3 and 4, Mariner 6, Mariner 7. All the while, the Soviet Union was not able to have a successful mission at Mars. Still, the United States still continues to lead in being able to land and operate on Mars effectively. Most recently, China was able to become the second planet to land a rover on the red planet. History for NASA's exploration of Mars somewhat begins with the Viking program. The Viking program had 2 main parts. It included an orbiter that would be in orbit around the planet. as well as a lander that would land on the planet. They did this twice. So there was 2 orbiters and 2 landers for the Viking program, a total of 4 spacecraft in total. The orbiters would take photographs and different messages, and they would also perform a radio relay between the lander and our satellite dishes back on Earth. The goal of the Viking program was to search for evidence of life on Mars, and this was primarily done through the 2 landers. Here are 2 images from the landers. Viking 1 down here below, landing in July of 1976. This shows the barren red plain of the Martian surface, and then a similar location in Utopia Planitia. Viking 2 landed a couple of months later in September of 1976. What did Viking find? Well, not much in terms of evidence for life on Mars. Both landers carried instruments designed to search for traces of life. What they would do is they would sample some of the Martian soil, gather that sample into a canister that was then used to run different experiments. One of these experiments included, there was 4 total experiments. One of them was the addition of water as well as various nutrients, and the instruments were designed to detect any changes in the gases that may be released from the soil. The idea here is that there are microbes living in the Martian soil, then they would absorb or eat the nutrients that were being given to them, and then they would release gas as a byproduct, and the instrument would be able to detect such gas. However, most of the experiments were negative, and one came back as inconclusive. This then leads us to Mars Pathfinder. This was our first rover on the red planet. Mars Pathfinder landed in July of 1997. It was named Sojourner, the rover Sojourner. It was carried to Mars in a large, basically like a large airbag that was dropped from a parachute and then bounced over the red planet before unfurling and allowing the rover off to then explore. Here is a model of the Sojourner rover analyzing a rock with its instruments on its nose. Here's an actual picture of the Sojourner rover operating on Mars. The Sojourner rover lasted for about 83 days. On Mars, we call a day a sol. We call this because a Mars day is actually not 24 hours. It's actually 24 hours and 37 minutes long. So it's not equal to one Earth day. So it lasted about 83 sols. So it's a little bit longer than 83 days. And this was a major achievement that it lasted so long because engineers had designed the Pathfinder rover to only last about 7 sols. And so it greatly exceeded its design capabilities. This then led us to the Mars Exploration Rovers, or the MER rovers. There were 2 MER rovers, and instead of looking for life, the MER rovers set out to follow the water. The theory is that water is essential for life on Earth, and therefore it may be essential for life on other planets. So if we can look for evidence of water, maybe then we can learn more about the possibility of life in the solar system. So this was the goal, was to follow the water, and this was done by 2 twin rovers designed very similar. This was Spirit and Opportunity. Spirit and Opportunity had large solar panels on their front to give them power, a lot of computer systems underneath that. They had then 6 wheels, a robotic arm that allowed them to measure and have instruments to sense different compositions of rocks. And then it had a mast on top of which were 2 cameras that served as the robot's eyes. 2 cameras are essential because those 2 cameras enable the robot to get a depth perception or a depth of field as to how far things away are. We use 2 eyes to get a depth of field, a depth perception to see how far things are away from us. And so the cameras on this rover did as well. And these were very impressive rovers. They were designed to last only about 90 sols. And in fact, they ended up lasting over 5,000 sols, which was about 15 years of operation. Spirit was sent to Gusev Crater. Gusev Crater turned out to not have very much water. It turned out to be a very rocky plain covered by volcanic rocks. And it seemed that this area maybe once was an ancient lake bed, but since then had been covered up by volcanic lava flows and did not preserve the evidence of that former lake. Opportunity had much more success. They ended up looking for evidence of minerals that could only form in the presence of water. From the satellite images that were taken of Mars, they detected the mineral hematite. Hematite is a mineral that only forms in the presence of water on Earth. And so finding hematite in the satellite images enabled them to choose the location for this rover. This was Meridiana Planum. And when they got there, they discovered that the surface was covered by all of these tiny blueberries. These blueberries, they're not real blueberries, but they're actually small nodules, small round balls of hematite that were formed in an ancient shallow lake environment. They're actually not blue, they're actually red. It is part of the false color image created by the cameras that highlight these objects as blue. However, once the scientists nicknamed them blueberries, the name kind of just stuck and they've been called this ever since. Here are some images of the Mars rovers on the surface of Mars taken by the satellites in orbit around Mars. We can see that the image here shows the the rover tracks approaching this large impact crater. And then we can see it double backing and then coming over here. Here is the Opportunity rover, and then you can actually see a little shadow here that shows its mast, camera mast in shadow. So we can see that it's been in operation here. Here's a zoomed out view of this crater, beautiful crater, and then the rover is over here in the corner. Okay, then this leads us to the Mars Science Laboratory, which was the next generation after the MER rovers. Here's sort of a little family portrait of the 3 different generations of rovers. We have the Sojourner, Pathfinder rover down here, then getting a little bit bigger to Spirit and Opportunity, the different Mars exploration rovers. And then finally, we have Curiosity, which is the name for the Mars exploration rover. It's very large, about the size of a car or a Mini Cooper, capable of doing a lot of different scientific investigations on Mars. However, to get this large of an object on Mars, scientists and engineers needed to develop a new way of getting it safely down to the red planet. Before, with the MER rovers and the Sojourner rover, they used an airbag system whereby a parachute would bring the airbag down to within a close distance of the Martian surface and then drop the airbag, allowing it to bounce over the surface. This airbag could not sustain the fall of an object the size of a car. So engineers needed to develop a new method for getting this object down onto the surface of Mars. This involved what was called a sky crane. The sky crane was very ambitious. Honestly, I did not think it was going to work, but it worked beautifully. The parachute would bring the sky crane down to a specific altitude, and then it would drop it. The sky crane was basically a jetpack. And the jetpack would then maneuver the rover into a specific location. And then once it was over a safe location to rest the rover down on the ground, it would then lower the crane's cables to lower the rover down to the surface. And then once the rover was safely on the ground, the jetpack would then fly away to a different location and crash land. NASA has been able to do this twice, and it is very impressive. There is a 7-minute delay between communications between Earth and Mars, which means that NASA scientists are not doing this landing by their own controls. They're not playing a video game trying to land this rover on the planet. All of this must be done through computer code. All of this is done autonomously and with the code that is put into the computers that are sent to Mars, which is very, very impressive. that they're able to sense the ground, take pictures of the ground, identify a clear landing site, and lower the rover all by itself. Curiosity was sent to a place called Gale Crater. Gale Crater is this very large impact crater here on Mars that is full of sediment. And it is thought that this location may record the different layers that have been built up throughout Martian history. And so the idea is to land on on the floor of this crater and then analyze the sediments up through this large mountain, being able to see how sediments have changed over the surface of Mars, many of which may have been formed during the flow of liquid water. And early on in Curiosity's mission, they did see evidence of flowing liquid water. If you remember back to last week's lecture on sedimentary rocks, we talked about conglomerate rocks. They had the pebbles and grains that had been rounded out and smoothed by their transportation. This is what the Curiosity rover saw when it first landed. It saw conglomerate rocks that had pebbles and cobbles that were rounded out and smoothed out by their flow along the surface. And so this was concrete evidence that material had been moved by flowing liquid water at some time in Mars's past. So this was very encouraging and led to a lot of promising results later on in the mission. Mars can get very dusty. Here is a look from the Curiosity rover of a dust storm and is looking out over the impact crater. This is the crater rim in the distance, and you can see it is very dusty during specific times of the year. Mars 2020 is NASA's newest rover to land on Mars. The newest rover started its journey in 2020. It landed in early 2021 and has been exploring Jezero Crater. The Perseverance rover at Jezero Crater is investigating deposits that may have once filled an ancient lake. This impact crater here that we see for Jezero Crater has what looks like a channel that enters in from the west, and at the nose of this channel is a large mound of deposits that we believe was an ancient delta. And so this rover will be analyzing those deposits for evidence possibly of the ancient lake, but hopefully evidence of life. Here is some video taken of the sky crane leaving Mars 2020 on the red planet. We see up here the image, a camera looking back up at the jetpack, firing down at the ground, keeping the rover safe with its cables. Then here is a view from the jetpack looking down on the rover as it is touching down on the Mars surface. And then here's a camera from underneath the rover as the engines are firing and it is kicking up all the dust around it. Mars 2020 carried a very cool experiment. They decided to test out the first drone on another planet, and they took along the Ingenuity helicopter. The Ingenuity helicopter has done many successful flights. Here's a animation or image of its first test flight. This represents the first flight on another planet. Hopefully, these will be included in future Mars explorations as a way to survey and plan future investigations. These drones can go out much further distances than rovers or humans can go, and they can take pictures of locations and send them back to assess them for future exploration. And then, like I mentioned, the United States is not the only country active on Mars any longer. In May of 2021, China became the second country to successfully land a rover on Mars. Here we see the rover on Mars. It looks like they've taken a selfie. He drops the camera on the ground and then comes back around to take a picture of it and its landing spacecraft. That is all I have for our exploration of the inner solar system. In our next lecture, the last lecture for Unit 3, we will wrap up with robotic exploration of the outer solar system.